Summer AP Physics. This is lesson number 8 on Newton's laws. So first we'll start off with the definition of mass. Mass is the amount of matter, that is just to say stuff, atoms and molecules, an object has in it. The amount of matter your body has in it does not depend on or does not change whether you're on Earth or in outer space, so your mass never changes anywhere in the universe. So the birthday girl has a mass of 20 kilograms whether she is on Earth or floating in outer space. In a couple lessons we'll see what the difference is between mass and weight. So the basic unit of measure of mass is the gram. One large paperclip has a mass of 1 gram. In physics, however, grams are what we use most of the time in chemistry because we're dealing with very small amounts of matter. But in physics, we generally deal with a unit of 1,000 grams called a kilogram. So the abbreviations are mass is small m, lowercase m, gram is lowercase g, and kilogram is lowercase kg. So again, your mass never changes anywhere in the universe. So Newton came up with 3 laws of motion, and this is really the beginning of modern physics. So the first law of motion says an object at rest remains at rest, and an object in motion remains in motion, constant velocity, until acted upon by an outside force. Now that was really revolutionary because anything in our everyday life, if we push something, it'll eventually come to a stop naturally. There's nothing that we can push that won't eventually come to a stop. And so it was believed all the way from the time of the ancient Greeks until Isaac Newton that if you wanted something to keep moving, even at a constant velocity, you had to keep pushing it. You had to keep putting a force on it. But Newton said no. He said, if you push something, it'll keep going forever and ever until it's acted upon by an outside force to slow it down or to stop it. And that was really a revolutionary idea. Now the second law of motion is that the acceleration of an object depends on its mass and the force applied to it. And this is really the first equation of physics, which is F equals ma, which we'll deal with here very shortly. And finally, the third law of motion is that for every action or force, there's an equal and opposing reaction or force. Now, you can temporarily have forces where there's not an exactly equal and opposite force, in which case the object would be accelerating. But generally speaking, eventually the forces have to equal out. They have to balance. So, what is inertia? The first law of motion, an object at rest remains at rest, and an object in motion remains in motion. That is constant velocity until acted upon by an outside force. This is known as the law of inertia. Inertia depends only on the mass of the object. So a heavier object, or a more massive object we should say, has greater inertia. So if you have a shopping cart at the supermarket and it's empty, it's very easy to start to speed it up, to get it going, and it's very easy to stop it if you want to stop it once it's already going. A heavier shopping cart, if it's filled with groceries, is hard to get going. You have to push really hard on it to get it rolling. And once it's rolling, though, it's hard to stop it. You have to really pull back on it hard to get it to stop. So that's the concept of inertia. That whatever the state of motion that something has, it doesn't want to change. If it's standing still, it wants to keep standing still. If it's already moving, it wants to keep moving. So getting an object to change its state of motion, whether that's standing still or moving, is hard to do if it's a heavier object. Okay, so what is inertia? When Stick Boy tries to push a car that is standing still, it is hard to get going. But when Stick Boy tries to stop a car that's already rolling, it's hard to stop. So that's the concept of inertia. The second law of motion, the acceleration of an object depends on its mass and the force applied to it. This equation is written in the form F equals ma. But really a better way to write that equation is to rearrange it to be A equals F over m. And that's because what it's really saying is the acceleration of the object is depending on the force in the numerator of that fraction. If the force gets greater, the acceleration will be greater. Or if the mass in the denominator of that fraction, A equals F over m, gets greater, then the acceleration will be less. So that's really a better way, is how do force and mass affect the acceleration? A equals F over m. But the way that it's written there is force equals mass times acceleration. So there's the mass. Stick boy's putting a force on it, and then it's going to accelerate if there's not an equal and opposing force. It will accelerate until there is an equal and opposing force. The third law of motion is for every action, that's Newton's word action, but it really means force, there is an equal and opposing force. If the forces on an object are not equal, then the object will accelerate until the forces become equal again. When forces are equal, that is balanced, the object is in equilibrium. When the forces are not equal, unbalanced, then the object is in disequilibrium. Objects in disequilibrium, unbalanced, accelerate until the forces are balanced. And that takes care of a brief lesson on Newton's laws, but Newton's laws will apply to everything we do in this course in AP Physics.